all, myself Dr. K. Kavitha, working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management, the ECE department, and my subject is the electronic measurements and instrumentation. In this subject, already we discussed in the lecture 1 what is the electronic measurements, what is the measurements and instrumentation, and what are the advantages of electronics and measurements and instrumentation, and what is how we are going to calculate, how we are going to measure the quantity of something. Already we discussed in the previous class. Okay, in this the continuation of the measurement is, so here continuation of measurement. In this, the measurement is the act of the result of quantitative comparison between the quantity. The quantity in the sense here we are going to compare the two quantities. One quantity is known to us and other quantity is unknown to us. So what is that? The unknown quantity is known as the measured. The known quantity is known as the standard. Okay, physical standard. So in this, there are the two whose the magnitude, the quantity here 3 depend standard. We are going to measure the two comparison between the 2 points, that is the measurand, and second one is the physical standard. Right? Okay. So here measurand is nothing but the physical parameter. And what is the standard is the quality of some kind as chosen the unit. Already we discussed in the previous class only. Okay, just I am revising that what we learned in the previous class. The quantity of some kind chosen as a unit. Already we discussed in the previous class only. Okay, the for any measurement we are going to consider the two comparisons. So that is the two units, that is the unit of measurement, and one more thing is the number. Okay, here I am going to find out that these are the instrument examples. Already we discussed in the previous class only. Once again I am repeating that by using the ruler, with the help of ruler we are going to calculate the length of the scale or anything. By using the stopwatch we are calculate the time. With the help of the stopwatch we are going to measure the time by using the thermometer. With the help of the thermometer we are going to measure the temperature. We are going to measure the temperature. By weight machine we are going to calculate with the help of that weighing machine we are going to calculate the weight. Okay, the measurement is given the number to that property. Okay, for example I am going to calculate in between the two comparisons, right? This is the tree 1 and this is the tree 2. What is the distance between the tree 1 and tree 2? Here I am going to comparison of those two quantity. So here the one is known to us and unknown, this is the unknown value. So these are the two measurement. For example, this is the 2 meters, right? 2 meters distance. Okay, the distance between two trees is 20 meters. Okay, 20 meter. So what is the 20? 20 is the, what is the 20 is the number. 20 is the number. What is the meter? So the meter is nothing but it is the standard unit of the length, standard unit of the length in between the transmit distance in between the tree 1 and tree 2. Here the result of measurement, it contains the two parts, that is the one part is the T1 and the second part is the T2. The distance between these two trees is 20 meters. The 20 is the number and meter is the unit of measurement. Unit of measurement. Okay, this about the instrument. By using this instrument, we are going to calculate some amount of the quantity is known as the measuring instruments. Okay, is known as the measuring instrument. Then after that completion of that, what is the measurement, what is the instrumentation, what is the measuring instrumentation, after this class we are going to calculate what is the performance characteristic, what are the performance characteristics when we are going to calculate, when we are going to measure one of the instrument. We are going to calculate the help of the two types, that is the unit of measurement and one more is the number. When we are measuring, before going to measure, we have the two performance characteristics are there. There are the two types of the performance characteristics exist in instrumentation instruments. They are static characteristics and dynamic characteristics. What is the static characteristic? The static characteristics is nothing but what we are going to use, that is the fixed one. We are going to use that. By using the static characteristic, the overall performance of an instrumentation is based on that its characteristics, right? So we are going to discuss the static characteristics in this the overall performance of the instrument that is based on its characteristics. Okay, the system characteristics are known to choose an instrument that most suited to particular measurement of this static characteristic. The set of criteria is defined as per the instrument which are used to measure the quantities. We are going to measure them that of the quantity of that measured unit, which are slowly varying with time or mostly constant, and that is not vary with the time. So what is the static characteristic we saw? Then I will give for example for static characteristic. Static characteristic is fixed time. This is the constant time. The constant time. We are going to take one example. We have to take one example is let us take one example. Suppose the master of the house is will keeping master versus what is worker. Okay, master versus the worker. Here the master of the house is the owner. He is sitting in the chair and the worker in the home, he is doing some work for master. So master is the giving the commands. He is sitting in the chair and he is giving the commands to that worker or slave. So what he is doing, he is sitting on the chair and giving commands to the slave that you have to do this, you have to do this, you have to take tea from me, you have to take tiffin for me, you have to take some snacks for me. Like that, the master is giving the commands to that slave, and the slave is continuously he is doing work. So what is the master is the static object. So the worker is continuously doing working. Owner position is constant. Whatever they giving the commands to the slave, right? The owner is nothing but the master. Master is constant. The owner is constant. This is nothing but the basic of that static characteristic. It is not varying time, it is constant time. Okay, the master is the constant and the time is varying for the slave. What is the dynamic characteristics? Okay, the worker is moving these here and there, right? The dynamic object is nothing but the worker is continuously he is doing work with the time. That is the dynamic characteristic. In the static characteristics, we have some parameters are there. That is the static characteristic is accuracy and the precision and the resolution and the type of errors. These are the static characteristics are do not change with time. Static characteristics, this is the constant time, and do not change with the times constant. The dynamic characteristics area it is continuously change with the time. The main difference between the static characteristics and dynamic characteristics is that in that static characteristics do not change with time. It constant. The dynamic characteristics the continuously change with the time. In the static characteristics, we have some parameters. What are those? Are the accuracy and precision and resolution and the type of errors. These are there in our syllabus, and the sensitivity threshold and linearity and etc is not there in our syllabus, but I will discuss what are the sensitivity threshold and linearity. Okay, so next we'll go to the what is the accuracy. What is accuracy? His accuracy is nothing but it is the degree of closeness. Okay, accuracy is nothing but this is the degree of closeness or exactness. The degree of closeness and exactness compared to expected value. Compared to the expected value, which the instrument's reading approaches the true value of the quantity to be measured. We are going to calculate the true value, the exact value, what is the closest value, then it is called as the accuracy. Accuracy, it is the degree of closeness or exactness so compared to expected value and which is given to the instrument reading approach the true value of the quantity to be measured. For example, if the actual value of the resistance, for example, the actual value of resistance we want to measure it is the 100 ohms, the actual value. At when we are measuring the value, the actual value of resistor, this is the actual value. When we are measuring that resistance, the value we are getting 101 and other user will get what we will get one user will get 101 and other user will get 102 and other user will get 100.2 and other user will get 100.1 like that. How much close to that value? It is 100. How much close the other user is getting like that? So how much close to that value to the value which are we are measuring? It is the true value of the 100 ohm. This is the true value. This is the 100.1 is the nearest value to the this is the closest value. So we are going to take this one. This is the accurate value. This is the accurate value. So these are the accurate is compared to the all other values where what are the nearest value we are going to compare and which is exact value or which is the closest value of the expected value we are going to take, that is the accurate value. Okay, this is about the accuracy means the conformity of truth. It means conformity. The accuracy means the conformity to the truth. Then this is called about the accuracy. The next is the precision. What is the precision? Okay, we are going to discuss what is the precision. Precision is a process. Okay, accuracy is a device. We are going to measure the value which is under the test. Okay, what is the precision? Precision is nothing but that is the process. The process we are going to measure the determining the unknown value. What is the difference between accuracy and precision is accuracy is a device we are going to calculate, we are going to measure the unknown value which is under the test. Okay, coming to the precision, where it is the process, it are going to calculate, you are going to measure the, you are going to determine the unknown value is called as the precision. Then next we are going to discuss what is the precision. Okay, what is, okay, before going to that precision, what is, we have one more thing is in the accuracy, we have the point accuracy is also is there. After in this accuracy, there are the point, that the point accuracy is also there. This next point accuracy. The point accuracy is specified at only one particular point. It is particular point. Accuracy is specified at only one particular point of scale. So what is the accuracy is? It is a device. We are going to measure the unknown value which is under the test. In the accuracy, point accuracy is there. And the point accuracy, we are going to take accuracy specified at only one particular point of the scale. Okay. Then next, accuracy as percentage of scale. Next, after this point accuracy, and one more thing is accuracy as percentage of scale span. In the accuracy, point accuracy is there. One more thing is accuracy as a point percentage of scale span. In this, what is the accuracy percentage of the scale span when instrument has uniform scale? When instrument has uniform scale, its accuracy may be expressed in terms of scale range. In terms of scale range. That is, for example, 0 degrees Celsius to 500 degrees Celsius. Okay, this is after we are going to calculate the percentage of 0.5 by 100 into 500. Then we will get the 25 degrees Celsius. So this is the percentage of scale form. Accuracy as a percentage scale span. This is about the accuracy. The percentage of true value, it is defined in terms of true value of that quantity. True value of that quantity. Next we will go, that is what is the precision. Okay, next we will discuss what is the precision. Okay. Next, what is the precision? Precision is closeness among the successive measurements. It is closeness among the successive measurement. There is a closeness among the successive measurement. The measurement of degree to which the successive measurement is different from each other. The successive measurement is different from the each other. For example, if I have 5 readings are, if I am measuring something, for example, the values are very close to each other. For example, 5 readings, when I am measuring the resistance of some value, the 5 readings are, we'll see, if I am measuring the 100 ohm resistance, so they are not equal to the true value. See here, when I am checking first time, it will get 100.1, 100.2, 100.3 and 99.9 and 99.5, like that we will get the values. These values are very close to the true value. It is different. The difference is small or high position. It is small or high. Okay, the position is different. The difference between the successive means is very less. It is called as the precision. Precision is nothing but the difference between the successive. The measurement is very close to its. It is called as the precision. What is precision? Is the definition is, what is precision means difference between successive measurement. Okay, difference between the successive measurements and its true value, it is called as the difference between the successive measurement. It is close to each other, then it is called as the precision. Okay, the precision is measure of reproducibility. The precision is measure of reproducibility. Reproducibility. Okay, what is the reproducibility? Is nothing but whenever we are measuring the resistance, right? Whenever we are going to measure the resistance, how much close the values are each other and how the readings reproduce each other, then this is called as a reproducibility. Okay, the degree agreement within the group of measurement is called as, and one more definition, the degree of agreement. Okay, the degree of agreement with the group of measurement is also called as the precision. The difference between the accuracy and resolution. We'll see what is the difference between this accuracy and precision. We'll see now. Okay, what is the difference between the accuracy and precision? For example, here is the center. This is the target value. Target is center in the circle, and now the arrow is placed at the target, the center of the distance. Every time archer is throwing the arrow in the circle, every time the placement is like but not change with the target. We have the values are very far to that true value, then that is a not accurate, that is nearest to the target, but it is not accurate. Precision is the closest value, is it is called as a precision. It is precision. The closest to each other, then it is called as the precision. It is not accurate, it is not it is far to that the target, the values are very far to that target value, then it is not accurate, it is a precision. Then the value is like here, it is the mean value. The mean value, it is the far to that accurate value, then it is called as a precision, it is not in accurate. Okay, this is the accuracy about, because the all of that measurement is close to each other, but these all are close to each other, but the far from the mean value. So then the low accuracy will get the low accuracy, and the high precision. Precision is high, the accuracy is low. Okay. Then this is one more thing. The second time we are going to discuss one more example. This is the center to that scale. The archer is throwing somewhat, it is less. Okay, so what happened here, the archer is throwing the arrow, all the arrows are like just one arrow is here, one arrow is here, one here, the here, all the arrows are very close to the true value, right? All the arrows, it is all the points are very close to the true value, but they are not close to each other, but they are not close to each other. It is very far, it is very close, but whatever the archer that is not close to each other, in this case the accuracy is high, and the what is the not precision, the precision is low, but the accuracy is high. High accuracy, and then we are going to draw that here. This is the mean value. The mean value, low precision, high accuracy. Okay, this about the second time. In the third time, what we are going to do is, it is very close to that target value, then how the accuracy is there in between the in between that accuracy, what we are going to differentiate that precision and accuracy. If it is very close to the target value, what is the accuracy is high or low, we'll see in the third case. Okay. Okay, we'll discuss in the next class what are the type, what is the resolution, and what are the types of the errors, what is the sensitivity, and what is threshold, and what is linearity, etc. We will discuss in the next class. Thank you.